Welcome again to another video. So this will be a continuation of the last video, which was for systems of linear equation. So while the systems of linear equation is solving multiple equation with multiple unknowns, we introduced some of the methods, which was solving in matrix way. Since we're talking about matrix, we also introduce, or we recall, the matrix, the definition of matrix, the characteristics of matrix, types of matrix. Here we will try solving one. So we have here example problem. So that is 11.11. Here we have three equations with three unknowns. The required method was Gauss-Seidel, but for lecture purposes, we will solve this in matrix inverse. I will show you how to solve it in Excel, and also we will try to solve it in Jacobi method, and also we will try to solve it in Gauss-Seidel method. So also he mentioned here, at least we need to have 5% of a relative error. Okay, so let's just solve it. So we have three equations here, which is three equations now. Let's just say this is equation 1. This would be equation 2. Here should be equation 3. And yeah, that will be our given. Let's just translate equation 1, 2, and 3 into matrix form. So we have here column for x1, column for x2, and column for x3, and your constant here, constant values. So for x1 we have 10, we have -3, we have 1. For x2 we have 2, -6, and 1 again. X3 is -1, 2, and then 5. For constants we have 27, we have -61.5, we have -21.5. So this is your matrix form. So let's just add another matrix, which is for the unknown variable, which is equals to this. So let's just say that this 3 by 3 matrix is your matrix A, and this will be your matrix B, and this will be your matrix C. So to solve for the unknown, our unknown here is x1, x2, and x3. So we need to solve for the inverse matrix of A, and then multiplied it with the constant matrix. So yeah, having that said, so let's just say this is letter A, matrix A, which is equals to no, it just equals. So okay, so the values are 10, -3, 1, 2, -6, 1, -1, 2, and 5. So no, then solving for the matrix, sige, let's just input here also the value for your matrix C, which is equivalent to 27, -61.5, and -21.5. Let's just highlight this, no, so para we are on track. Perfect. So finding the matrix inverse, so a -1 such that your -1 should be upper script. Just change this. So superscript. So -y, which is equals to so yeah. So since the matrix given is a 3 by 3, so we will highlight also 3 by 3. Since the resulting value for inverse matrix is also an 3 by 3. So we will just input a formula here, so that is equal, then function for inverse matrix is M inverse. So that is M inverse. And we need to highlight the matrix, which is this, and close parenthesis. But before we highlight here, before we highlight, we press the enter, we press the control shift first before pressing the enter, so that we will fill up all the values. So that should be pressing control shift then enter. So that is your values, no? So ato lang ni i-highlight in a different way. So yeah. Yeah. So that should be your values for your inverse matrix. So finding your B, that should be equals to your x1, your x2, your x3, no? So since we have 3 values for your unknown, so we will highlight 3 cells also. We input another formula here. So since our matrix B is just multiplying the matrix inverse A times the C, so that is equivalent to equals to M multi. So M multi function is a product for the matrix, multiplying products and multiplying the matrix, no, operation. So we will highlight this as our first array, and for C that will be our second array, close parenthesis. So before we before we start with pressing enter, I know, before we press the enter pala. So again, we need to fill up all of the values, three values, no? So we will press Control Shift Dion Enter. So that is your value for your x1, your x2, and your x3. Okay, so that is how you solve for matrix inverse method. So if you want to solve it in LU decomposition, you can do that. So however, in this video we'll be just solving in M inverse, matrix inverse method. So how about trying it in Jacobi method? So let's just copy the problem. So still we have equation 1, equation 2, and equation 3. So for Jacobi method, um, the process for Jacobi method is deriving equation 1, 2, 3, such that the what remains on the left hand side will be x1, x2, and x3. And same process with simple fixed point iteration, no? So deriving equation 1, 2, and 3 to create iteration equation. So for equation 1, that should be 10x sub 1 plus 2x sub 2 minus x sub 3 is equals to 27. So your x sub 1 here should be 27 minus 2x sub 2 plus x sub 3 all over 10. So for equation 2, that is negative 3x1 minus 6x sub 2 plus 2x sub 3 is equals to negative 61.5. So your x sub 2 here should be negative 61.5 plus 3x1 minus 2x sub 3 all over negative 6. And your equation 3 here, that should be x sub 1 plus x sub 2 plus 5x sub 3 equals to negative 21.5. So your x sub 3 here should be negative 21.5 minus x sub 1 minus x sub 2 all over 5. Okay? Okay, so let's solve. Okay, we need to create a table here. Before we create a table, so let's just declare the iteration equation. Therefore, the iteration equation so equations are, so for equation 1, that should be x sub 1 superscript I plus 1 is equals to 27 minus 2x sub 2 I plus x sub 3 superscript I. So for 2, we have x sub 2 I plus 1 is equals to negative 61.5 plus 3x 1 I plus x sub 3 no. That should be negative 2x sub 3i all over negative 6. Kanina pa ni over. Ni divided by 10. Forgot to write. So for equation 3, we have x sub 3i plus 1, which is equals to negative 21.5 minus x sub 1i minus x sub 2i all over 5. So notice that we are using Jacobi method so therefore your updated values will be reserved for the next iteration. So yeah, let's create now the table. So we have here iteration, which is equivalent to your x1, your x2, and then your x3. Then error not values. So error for 1, and for 2 and 3. So yeah. So first iteration, initially for your iteration, so we have 0 initial guesses, no? Again, this depends on you. So pwede ka magbutag 1 or bisag unsa na initial guess. I prefer zeros for the initial guesses. So first iteration, so applying those formulas, which for x1 we have parenthesis 27 minus parenthesis 2 times the x2 plus x3, which is this, close parenthesis divided by 10. Second equation should be negative 61.5 plus parenthesis 3 times x1 minus parenthesis 2 times x3 divided by negative 6. And we forgot to put parentheses here. Be careful with parentheses, no? It should be that. So for lastly, for x3, we have parentheses negative 21.5 minus x1 minus x2. We forgot to put equal. So that is this minus x2 close parenthesis divided by 5. Okay, so we don't wala pa tayo ma-compare diri na error, so because your initial guess is 0 here, so of course your error here should be 100%. So let's just move it up here. for the second iteration. So last solutions mo nitong nakuha no 0.5, 8 and -6. Let's try if we can get it here. So at second iteration, we can now solve for the relative error since we have two values. So let's just put it in absolute. So that should be this difference between this and this divided by the new. Okay, that should be that. So kanino ay mo na yung error. So let's just drag it all in. Let's just create so ato lang i-drag. Okay, so what is asking in the problem is just 5% relative error, and we can see that at fourth iteration we can get the value, we can have a sufficient value for this particular problem, but exceeding or getting exact values for same with the value for matrix inverse we did get after 6 iteration, I guess. So let's just highlight this. So mana siya no. How about for Gauss-Seidel? So your Gauss-Seidel, here, mo ni imong Jacobi. Iteration equation for Jacobi. Iteration equation for Gauss-Seidel. So for equation 1, so that will be again the same, but what we are changing here is the iteration superscripts. So that will be 27 minus 2x2i plus x sub 3i divided by 10. Since you have a first iteration equation, yeah, what you will get is the current values, no? I know the initial guesses for x sub 2 and x sub 3. So for second equation, we have x sub 2 I plus 1. Here you can change, you can update the value for your x1 here. So that should be 3x1 then I plus 1 minus 2x sub 3. So for equation 3, updating the values again. So I plus 1, that should be negative 21. Kalimot ko sa negative 6 So that is negative 21.5 minus x sub 1 I plus 1 minus x sub 2 I plus 1 all over 5. So this is for Jacobi ha. So let's just compare, no? So for Gauss-Seidel, so what we need is to update the values for your equation 2, which is moving it to the latest value of x1 and moving to the latest value for your x sub 3 here, should be less. So ako lang ki-move ang values, no? So nanga-change na siya by dragging. So as you can see, in the fourth equation, nakuha niya ang 5%, but the values for the fourth equation is enough, no? To match the values for the matrix inverse, which is this. So as you conclude, yeah, Gauss-Seidel has a better convergence compared to Jacobi, no? Because you are getting the updated values. So yeah, and